In this video, we're going to talk about relations, functions, domain, range, and vertical line tests. So let's start with the word relations. Any relationship between two variables. When you have two variables, you automatically have a relation. For example, it can be X and Y. So let me just write here relationship. It doesn't have to be X and Y. It can be anytime you're comparing two things, hours that you worked and money that you earned. So a relationship between two quantities, it's automatically a relation. Now, for that relation to become a function, something else must be happening. A function is something extra, something more. So for the function, we say for every input, there is exactly one output. There is exactly one output. And I'll explain to you what this means in detail when we do an example very shortly here. So for every input, there is exactly one output. We simply call it X's cannot repeat. X's cannot repeat. We're also going to be talking about domain. Domain is just listing the X values. And range, listing the Y values. I'm also going to introduce to you what we call the vertical line test, and I call it VLT, vertical line test. This is a method that we refer to only when we have a graph. So it's useful only when graphs are in front of us. Useful for graphs. And I'll explain how the process works. Useful for graphs. So let's start with a specific example. So I'm going to write here some order pairs, -3, 2, -2, 4, 0, 5, -2, 6, and 3, 8. So as soon as I have order pairs, I have some X and some Y's, and to be specific, it's 5 X's and 5 Y's, I automatically have a relation. So I have a relation in front of me. Now for that relation to become a function, as we said before, I have to be careful. I have to go in there and check the X's. So let me go ahead and do that right now. Just gonna check the X's. -3, -2, 0, -2, and 3. So you can clearly see that yes, I have X's that are repeating. -2 and -2, they're the same X, and they are going to different Y's. This -2 goes to 4, and this -2 goes to 6. So because the X's are the same and they're going to different Y's, this is not a function. This is only a relation. X's cannot be repeating. Let me give you another example. 1, 2, 2, 2, and 3, -7. Again, I'm going to go back and check the X's here. 1, 2, 3. I automatically have a relation because I have X and Y's, but when I check the X's, all the X's are different. So this is a function also, not just a relation, but a function also. It is a relation, but it's also a function. So let me introduce to you domain, as I said before, and the range so you know how to put them down. For domain, when you're asked to put down domain, you're really asked to list down the X values. So we'll put brackets, and we'll list our X values in order from smallest to biggest, and they should be separated by commas. So to be specific here in this function, I would say 1, 2, 3, and I'm closing my brackets. That's the domain of this function. For the range of this function, again, I list the Y values in order from smallest to biggest. Remember, for the range, for the y values, they can repeat. There's not a problem there. So because I have y values 2 and 2 that are repeating, I'm going to list that only once, but I should start from the -7 because that's the smallest. So that's my range. Now, sometimes you're not just going to be given only order pairs. You can be given a graph, or you can be given order pairs in the form of like a mapping. So if we go ahead and do this mapping here, so you can see how it looks like, you have your x values, and your y values are -7 and 2. So here's what's going on. You have 1 that goes to 2. You have 2 that goes to 2. And you have 3 that goes to -7. So all the x are different and all the x are going somewhere, and that tells us that it's a function. It doesn't matter that both of these x's go to 2. That is not a problem. So this is a function. Now, if I go and show you the mapping of the first relation with the green here, that we said it wasn't a function, let's go right here and do that. We have the x's. If I go from the smallest x, I believe the smallest x here would be -3. Then I have -2, 0, and 3. My y's are 2, 4, 5. I guess they are in order. 2, 4, 5, 6, and 8. So here's what's going on. -3 goes to 2. -2 goes to 4. 0 goes to 5. -2 goes to 6. And 3 goes to 8. So you can clearly see you have the x value of -2 twice. It goes to 4 and 6. So that is not allowed when you're talking about a function. So you can repeat the y's, but you can't repeat the x's. That's the problem. All right. The last thing I wanted to introduce to you would be the vertical line test. So let me go to a new screen to show you how that works. So if you don't have order pairs in front of you, in order for you to decide if you have a function or just a relation, you will have the graph if you don't have order pairs. So let's go and check 2 different graphs here. All right, I'm gonna make my graph with another color. Here's my first graph, which is a line that is increasing from left to right. The second graph would be just dots. So let me just, here's one dot, another, and so on. So for the vertical line test, as the words are saying, you using a vertical line. You can bring your own vertical line anywhere you want to. You can use the y-axis. So anywhere you want to on this graph for the purple line, if you bring a vertical line, just go with another color here, you can clearly see that the vertical line would cross your graph, not the x and y-axis, only your graph at only one point, 1. You can use the y-axis. Your y-axis will cross your graph at 1 point, 1, 1. You can bring another line, another vertical line, anywhere you want to. So if you repeat the process anywhere on this purple line, bringing vertical lines, you can clearly see that any vertical line will cross your graph at only 1 point. If it's at only 1 point, it is a function, and we say it passes the vertical line test. Passes the vertical line test. Now, let's go to the other graph. This is just dots, doesn't matter. So if I go bring a vertical line where the y-axis is, on the y-axis, because it's a vertical line, I can use that, well, we can see that the graph crosses at only 1 point, which is fine. If I go and bring a vertical line right here, though, this is 1, 2, 3, 4, and so on. So no, if it's more than 1 point, the answer is no, it is not a function. Not a function. So we say it does not pass the vertical line test. Doesn't pass the vertical line test. So those are two simple examples. Let me just show you two more. Create some other graphs here. Here's an X and Y axis, what I'm going to do my first. Here's an X and Y axis, what I'm going to do my second. So for the first, I'm going to make my graph looking like this. It's an upside down V. You're going to learn more about those graphs in Algebra 2. And here, make a parabola that it's shifted. And again, you're gonna do parabolas maybe in geometry a little bit, but more in Algebra 2. So same concept, because I have the graph in front of me, I will be using the vertical line test to prove if it is or if it's not a function. So anywhere on the purple graph, if you can use your hand if you want to, and trace it over as a vertical line. Anywhere you go and make a vertical line, the answer here would be yes, because my vertical line at any point will be crossing the purple graph at only once. 1, 1, 1. So this is a function. It passes the vertical line test. If you go here, you can clearly see from the y-axis, which is supposed to be a vertical line, that we're having a problem. 1, 2. You can bring another one. 1, 2. You can bring another one. 1, 2. Someone might say, oh, how about this? It crossed at only 1 point. Yes, but anywhere else, if you grab a vertical line, it's going to be more than 1 point. So because of anywhere else is not 1 point, the answer here would be no, not a function. It does not pass the vertical line test. So there you have it. Range, domain, function, relation, and vertical line test.